So this is the one of the problems. Wait a second. Yeah, this is one of the problems that a student asked to solve. Consider the figure below, and then you have a street light that is held by two equal forces, 60 newtons, um, and it's asked what is the resultant force exerted by these two cables supporting the traffic light. So basically, what you do, you take this object, and then you do free body diagram on it. Don't know why these things happen. So the free body diagram here is the mass of this street light, whatever mass it has, and we have a 60 newtons force, another 60 newtons force, and the angle 45 implies this angle is also 45. This angle is also 45. So if you want to find the resultant force of this 260 newtons force, it's simple, right? When you project these two forces in the x direction, so here in the x direction to the right, you have a projection that is 60 cosine of 45, and in the other direction, the other force will project as negative 60 cosine of 45. So when you add these two components, they cancel out, right? You have a positive fx to the right and a negative fx to the left, so they cancel out. But when you project this 60 Newton force in the y-axis, angle is 45 as well. So in the x direction, what you got is for the force on the right hand side, 60 sine of 45. And the other force also project in the y direction, plus 6 sine of 45. So it's going to be Fy, the projection of these two forces, the resultant in y, is going to be 2 times 60 sine of 45. And the direction is pretty much y direction, right? Because your x direction, the projection in there is 0. What is the weight of the light? Well, now it's a Newton's second law. In case the street light's not moving, the resultant of these three forces must be 0, which means our Fy, which is upward, minus Fg, which is downward. So Fy minus Fg is equal to 0 because there is no acceleration. Therefore, the weight is equal to that resultant force. That's why I have equal numbers in there. The other problem the student asked to solve, I think was the 19. A frictionless plane is 10 meters long and inclined. So we have something like that. This angle is 10 degrees. And is inclined. The plane is 10 meters long, so this whole distance here is 10 meters. And is inclined with an angle of 38 degrees. A sled starts at the bottom with an initial speed of 6 meters per second up the incline. So you have some sled here that start moving up with this initial velocity, and it's frictionless, so friction is not an issue. When the sleds reach the point at which it momentaneously stops, the second sled is released from the top of the incline with an initial velocity vi. So let me repeat this. situation here. So it said when this first sled moves up and gets to this point, okay. So when it gets to the point where its velocity is equal to 0 meters per second, a second sled is released from the top of the incline with an initial velocity Vy. So we have a second one here that is released with an initial velocity Vy meters per second. Both sleds reach the bottom of the incline at the same moment. So the time it takes this sled to go all the way down, which means in 10 seconds, covering 10 meters, is the same time that it takes this guy to go all the way down. So that's the condition. So time is the same. Determine the distance that the first sled traveled up the incline. So let's find that. The initial velocity is 6. Final velocity for the first sled is 0. And what is the acceleration? So to find the acceleration, you place the sled somewhere in the incline, and then you do free body diagram on it. Free body diagram in I don't know. Hate that. It is. I will do right here. So the free body diagram is a downward gravity force. You have a normal force, and pretty much that's it. You don't have any other force acting on it, since friction is not an issue anymore. So if you call this direction as being your y direction, and the one along the incline as being your x direction, okay, then the acceleration of this sled is equal to this angle here is theta, right? This angle is, what is the angle? 38 degrees. So acceleration is going to be g sine of 38, right? We have one vector acceleration going down, which is given by g. So its projection in the y direction gives the acceleration of the sled. So because of that information, you know, final velocity is given, the initial velocity is given, and then you can apply Bernoulli. Initial velocity square. I'm sorry, final velocity square. No, initial. Sorry. Let me erase. Initial velocity square. Initial velocity square is equal final. Man, I think I'm really sleepy. Okay, let's try again. Final velocity square is equal initial velocity square minus the acceleration 2 times g sine alpha sine. What happened? 2g sine of 38 times del x. So then you can find del x. So your del x, right here. So your del x is equal to 36 divided by 2g sine of 38. Sine of 38. So you apply Bernoulli given the conditions provided by the problem, right? And then determine the initial speed of the second sled. So you can use, since the time that took the first sled to go down is the same time that took the second sled to reach the initial position in this, the bottom position of this incline, the time the same. So you can use the fact you know the acceleration, you can use the fact you calculate del x, and then you can find the time. the time it took this sled to go all the way up, which the same time it took to go all the way down, which the same time that took the second sled to go down. So then you could apply Bernoulli for the second sled, in a sense. Its initial velocity you want to find. Um, you know the distance covered, 10 meters, and you know the acceleration, you know the time. Then you can find, no, the initial velocity you don't know. That's the only unknown you have. But you know the distance covered, you know the time, and you know the acceleration, which is g sine alpha. Okay, sine of 38. This problem is a little bit tricky. It has several layers. So this quiz that's going to come up is a quiz that is more read on applications of basic equations. So, but pretty much that's it.